I'm Serene. Today I'm going to be explaining a topic 3 question on thermal physics, and the question code is provided below. First, I'm going to read the question and specify its conditions. An ideal gas has a volume of 15 milliliters, a temperature of 20 degrees Celsius, and a pressure of 100 kilopascal. The volume of the gas is reduced to 5 milliliters and the temperature is raised to 40 degrees Celsius. What is the new pressure of the gas? According to the IB, an ideal gas is a gas with no intermolecular forces that obeys the ideal gas laws PV equals nRT at all temperatures, pressures, and volumes. And the sum of kinetic and potential energy of the substance is isothermal. Okay, here we're gonna use the combined gas law where P1 is the first pressure, P2 is the second, V1 is the first volume and V2 is the second, T1 is the first temperature and T2 is the second. The combined gas law is a combination of the three previously known laws, which are P times V equals a constant, V divided by T equals a constant, and Gay-Lussac's law, where P divided by T equals a constant. Therefore, the formula of the combined gas law is PV over T equals a constant, where P is pressure, T is temperature, and V is volume, and K is constant. First, on the diagram, we see Boyle's law, where P1 V1 equals P2 V2, and this means that pressure is inversely proportional to volume. So when pressure increases, volume decreases, and vice versa. Then we have Charles' law, where V1 over T1 equals V2 over T2, and this means that they are proportional. So a volume is proportional to temperature. Then Gay-Lussac's law is very similar to Charles' law, where P is proportional to T. So P1 over T1 is proportional to P2 over T2. These individual laws apply considering that the variable that isn't in the law or the other variables that aren't in the laws are kept constant. For example, in Boyle's law, temperature needs to be kept constant. So the combined gas law is just a combination of all these variables put together. So you see P and V are together because they're inversely proportional, and they're over T because T is directly proportional to V and P as shown in the other laws. Obviously, before you substitute in the combined gas law, there are certain conversions you need to make. Pascal can stay the same because it's in kilopascal. And then for temperature, you need to convert to Kelvin because you're not using difference, you're using the actual temperature value. So you do 20 plus 273 and get 293 Kelvin. For volume, you could keep it the same because the ratio is going to cancel out because there's a V in milliliters on both sides of the equation. But it's better to convert to meters cubed. So you do 15 divided by 1,000, you get 0.015 meters cubed. You do the same exact process for T2 and V2. You just add 273 to T2, which is 40 degrees Celsius, and you divide 5 by 1,000 to convert to meters cubed. And obviously in this question we're solving for P2, so we do not have a value for that. Okay, so now I substituted P1, V1, T1, P2, obviously we don't have it yet. V2, I substituted it, and T2 with all the values that I converted. Then to isolate the P, I multiplied the other side of the equation by 313 and I divided it by 0.005. After doing all the simple algebra and everything, I got an answer of 320.4, and the closest option to that is B, which is 320. Any other answer would be a result of miscalculation, not completing the proper unit conversions, or using the wrong equation, and 320 is the only correct possible answer. Thank you.